the last part of these quadratic notes, we're still looking at example 3 and 4 on that last page. And we have a function in standard form already. We want to put this in vertex form. So our vertex form, just remind yourself what it is. Y equals a times x minus h squared plus k. This would mean that a is 1, b is negative 8, and c is positive 10. We're going to take that information and find the vertex. So we need to do negative b over 2a. This is the first method we're using. So negative b over 2a would be negative 8 over 2 times 1. Negative makes that positive 8. So positive 8 divided by 2 is 4. Our vertex starts out as 4 something. We just got to figure out what is the y value. So if I plug that 4 in, I'd have 4 squared minus 8 times 4 plus 10. You can put that in your calculator if you need to. We get a value of negative 6. There's our vertex. Let's take that and put it in here. So a is 1, x minus 4 squared minus 6. There's our vertex form. B wants us to find the maximum or minimum. Our parabola is opening up because a is positive. That means we have a minimum in this case. It doesn't say when, it just says find the maximum or minimum value. So the minimum of negative 6, because we're looking at the y value. If it asked when that happens, it's when x is 4. C is asking about the x-intercepts. Now, if you try to factor this, you'll see that it does not work. So we end up having to use the quadratic formula. If you don't remember the quadratic formula, it's right here. So this is probably something I would highlight. Just to memorize. But I'm going to apply this into these a, b's, and c's from our function. So it says x equals negative b, which is negative 8, plus or minus the square root of b squared negative 8 squared minus 4ac. A was 1, c was 10, so I plugged those in. All over 2a, so 2 times 1. And we start to simplify this as much as we can. I'm going to do the first part, so negative makes that positive 8. But when we get to the radical, you want to put in your calculator just what's underneath the radical sign. So that would say negative 8 squared minus 4 times 1 times 10. Gives me a positive 24. All over 2. This can still simplify. And so when I look at simplifying radicals, hopefully that's something you've seen before, but if not, I'm just going to write it on a sticky note here. So the square root of 24 can break down into the square root of 4 times the square root of 6. And I chose the square root of 4 because it's a nice, perfect square root. Square root of 4 is 2, so that becomes 2 square roots of 6. You want to break down your radicals as much as you can. There's no other perfect square that's going to go into 6. I can't put another 4 in there. So if I use my calculator, the square root of 24, this will also reduce it down if you have this kind of calculator to 2 square roots of 6. Not every calculator will reduce your radicals for you. But I can simplify our fraction to 8 plus or minus 2 square roots of 6 over 2. We still want to reduce our fraction. So I'm going to be looking at all of the whole numbers, 8, 2, and 2. Every single one of those can reduce. I'm not reducing the square root of 6 because it doesn't have factors that reduce into it. But 8, 2, and 2 can all reduce by a factor of 2. So I'm going to divide that out and say 8 divided by 2 is 4. 2 divided by 2 is 1, so 2 divided by 2 is 1. And normally you're not going to see that if it's divided by 1, so I'm just going to write it out as 4 plus or minus the square root of 6. And those are our x-intercepts. We have two of them, one that's plus and one that's minus. So x-intercepts would say 4 plus the square root of 6, 0, and 4 minus the square root of 6, 0. If we needed those in decimal form, you could put that in your calculator and do 4 plus the square root of 6. It gives it back to you the same way, but if I press this equivalency button, it will turn it into a decimal. So I've got 6.449 as a decimal. And you could find the other one as well. We want to then move on to our y-intercept. This is the value of y when x is 0. So if I plug that in, 0 squared minus 8 times 0 plus 10 should come out nicely to just be 10. So there's our y-intercept, 0, 10. And we can graph the function. I like using transformation form to graph. So if I go right 4, let's zoom in a little bit. 1, 2, 3, 4. We're going to go down 6. 1, 2, 3, 4, 5, 6. The a value in our function is 1, so it was not vertically stretched at all. That keeps with the parent function shape. It does go up, so I'm going to go right 1, up 1 from the vertex, and left 1, up 1 from the vertex. Then we go out 2 from the vertex, so out 2, up 4. 1, 2, 3, 4. Out 2, up 4. Out 3, up 9, so 4, 5, 6, 7, 8, 9. And then same thing over here. Out 4 would be up 16, so out 4, 1, 2, 3, 4, up 16. Ends up being all the way up here at 10. Out 4, 1, 2, 3, 4, and up 16. You did find your y-intercept. So if we knew that the y-intercept was 0, 10, you could plot that on your graph. But something you'll see is that it crosses the x-axis at some values between 1 and 2 and some values between 6 and 7. When we were finding those x-intercepts, we did 4 plus square root of 6 gave me 6.44. 4 minus the square root of 6 is 1.55. So it does cross between 1 and 2, 1.55, and between 6 and 7, 6.449. All right, last one here, example 4. We have something that's already in transformation form. So let's make a note of that. So this is in transformation or vertex form. If it's already in transformation form, then we're going to need to multiply it out so that it will be in standard form. So let's give you at least an example of how do we do that. I take my function, rewrite it, and then we do our order of operations. Order of operations say do exponents first. That would be -3 times x minus 2 times x minus 2. So something squared is just multiplied by itself. If you know how to multiply binomials, you can go ahead and do that part. And so we'd be multiplying out x minus 2 times x minus 2. Let me go back to this sticky note here. we'd be doing x times x, which is x squared, x times negative 2 into negative 2x, negative 2x, positive 4. And we can combine like terms. So that's what we're doing right here in this multiplication step. But we have to multiply or distribute a negative 3 to everything as well. So that'd be a negative 3x squared, a positive 12x, a negative 12, and then we still have that plus 7 on the end. So the last operation is addition. We can combine like terms. So I can combine this negative 12 and positive 7 and just simplify. So negative 3x squared, positive 12x, and then negative 12 plus 7 would be negative 5. So now we have something in standard form. B asks about find the maximum or minimum value of the function. We can do that in standard form by using negative b over 2a, but if it was already in transformation form, don't put more work on ourselves. Let's find our vertex. Our vertex moved right to up 7, so it becomes 2, 7. Our function flipped because a was negative 3. In that case, we have a maximum. So we have a maximum of 7, that's the y coordinate, and it occurs when x equals 2. So it didn't ask about that section there, but I just want us to notate at least the maximum is 7. It happens when x is positive 2. If we find our x-intercepts, I'm looking at our standard form. So negative 3x squared plus 12x minus 5 equals 0. That function is not going to factor, so I'm going to have to use our quadratic formula. The same thing when I kind of recommended you just write out your transformation form a lot. Let's write out our quadratic formula. So negative b plus or minus the square root of b squared minus 4ac all over 2a. That's something you have to have memorized. It's not going to be given to you. So if I plug this in here, negative b would be negative 12 plus or minus the square root of b squared. So 12 squared minus 4 times a, which was negative 3, c, which is negative 5. All over 2a, so 2 times negative 3. And then we put this in our calculator. So that's negative 12 plus or minus something, square root of something, over negative 6. Let's just figure out what goes underneath that radical. So I'd have 12 squared All right, 12 squared minus 4 times negative 3 times negative 5 gives me 84. We want to reduce that radical, so I would say negative 12 plus or minus whatever that is over negative 6. Let's see. What is the square root of 84 reduced to? And it's 2 squared to 21. And we keep reducing. When I'm looking at how this reduces, I'm thinking about how does 12, 2, and negative 6 reduce? What things go into all of them? And so I could divide by negative 2. If I do negative 12 divided by negative 2, I get a positive 6. If I do 2 divided by negative 2, I'm going to get a negative 1. But I'm going to leave it as just a 1, a positive 1. And I'll tell you why here in a second. Negative 6 divided by negative 2 is a positive 3. So the reason I left this as a 1 here is because when you're doing plus or minus, it's going to take care of it. So let's say I have 6 plus or minus negative square root of 21 over 3. That's 6 plus negative square root of 21 over 3, and 6 minus negative square root of 21 over 3. Plus and negative is just your minus, and minus and negatives is just your plus. So we don't need to put another negative here because that plus or minus is already taking that into account. So this would simplify all the way here. If this was a word problem, we'd get our decimals and find that in context. But if it's not in a word problem, you want to find the exact value. Now, if you have one of these calculators, it can put that whole fraction in. So negative 12, let's do plus 2 square roots of 21 divided by negative 6. And it'll give you that thing. It just comes out backwards. It always puts the radical first. I'm not sure why this calculator does it that way. But if you don't have one of these calculators, just know how to simplify your fractions by looking for a common factor in there. All right, last thing, D says find the vertical or y-intercept. That's the value of y when x is 0. So let's plug that into our standard form. So negative 3 times 0 squared plus 12 times 0 minus 5. If we work that out, I'm going to get a negative 5. So there is the last piece we need for our function. Now I can graph it because I've got all these different pieces. So we found our vertex to be 2, 7. So I'm going to go to 2, up to 7. We found a y-intercept of 0, negative 5. So we can put that there. Our x-intercepts are not pretty. So we would need a decimal if we were going to graph those, but we have the transformation form. So our transformation form had a negative 3 out front. We know it had a vertical stretch by a factor of 3. So instead it's going down. I'm going to go out 1 and not down 1, but down 3. So out 1, down 1, 2, 3, put a point. Go on the other side, out 1, down 1, 2, 3, put a point. Out 2, down 4 would be the typical patterns because 2 squared is 4, but we need to vertically stretch that by 3. So 4 times 3 is 12, so I'm going to go out 2 from the vertex and down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If we do it on the other side, you'll see you end up at the y-intercept. So I have enough to make a sketch here. And our graph is really skinny because it had a very steep vertical stretch. The very last part of these notes, it's really just there because of something that you'll see in WebAssign, but it has some weird coefficients, and that's okay. Given this f of x, we want to find the axis of symmetry and the x-intercepts. The axis of symmetry is from that negative b over 2a. If I plug that in, negative b over 2a would have a negative 2 square roots of 2 over 2. This part reduces. 2 divided by 2 is just 1, so I'm going to have a negative 1 square root of 2. That is your axis of symmetry. So x equals negative square root of 2 is your axis of symmetry. Now the x-intercepts are a little bit trickier because we have to use the quadratic formula. So if I did that, x equals negative b plus or minus the square root. Our square root is 2 square roots of 2 squared. Put that in parentheses. Minus 4 times a times c. All over 2a. So what's nice about this is that we're going to be able to use a calculator. So I get negative 2 square root of 2 plus or minus the square root of something. Let's figure out what that something is. So inside we have parentheses, 2 square roots of 2. Get out of the square root. So that whole thing is being squared. Minus 4 times 1 times negative 3 gives us the 20 over 2. We still have to simplify that. So negative 2 square root of 2 plus or minus, let's see, what is the square root of 20? It's 2 square roots of 5. And then we reduce. So I'm looking at the coefficients in front. I've got 2, 2, and 2. I can divide everything by 2, which gives me negative 1 square root of 2 plus or minus. If I divide that, that's a positive 1 square root of 5. That really forces us to understand our algebra skills. So if there's a part of this that you need to go back and review a little bit, or if you have some questions about, definitely look up some of the other videos like factoring or maybe even simplifying the radicals and things. That could be helpful. There's a lot of practice in WebAssign and on the lab manual.